Hi, I'm Nirmal Malapaka. I work for Wolfram Research, and I'm a kernel developer here. My talk today is about date visualizations in the Wolfram language. So before I get started, let me give you a brief overview of what I'm going to be talking about. I'll be talking about the very basics of representing dates in the Wolfram language. There is a lot of functionality around working with dates in the Wolfram language. Most of it is going to be out of the scope of this talk. What I will be dealing with is the interaction between the different date representations and the visualization functions. So we'll take a look at a few date plots and how they visualize data. Then we'll take a look at the features and options that give us a way to work with dates from within the visualization functions. And then finally, we'll take a look at a few applications built on top of the date features, as well as date plots. Thank you. Okay, so let's get started. The Wolfram language has a few ways to represent dates, and here's a list of some of the representations. And I've tried to list them out in the order of their increasing sophistication, in the sense that as you go down this list, you can hold and pack more information into the representations. And this is important from the point of view of visualization functions, because the more information we have inside the visualization functions, more we can do with them, and the richer the visualization will look. So absolute time is the simplest way to represent date information in the Wolfram language. And we set it to 0 on the first day of the year 1900. And then we count the number of seconds. So here, for example, we have a list of list of absolute dates represented as absolute time and value pairs, and we feed that into the visualization function. In this case, date list plot, and as you would expect, you see the time being plotted on the x-axis, as you'd expect. Date string and date list are a more human-readable form of the representation, and you will be able to see this in any of the applications or on the web where you come across timestamps, and the same thing, you can again plug this into the visualization functions, and they will plot the data. Date object is a more packaged and internally consistent representation for dates, and this gives us features like, for example, validation. So we have functions like date object queue, which should be able to make your life easy in terms of processing and filtering data before you pass them on to visualization functions. Time series is an even more packaged representation, where you can give it times and values, and it'll put it into a time series object, among other things. And time series has a whole slew of features which will help you sort of fine-tune what kind of information you want to encode in that object. And there's a whole talk on time series tomorrow. But time series, event series, and other temporal data are all accepted by date visualization functions, and they will plot them directly. So this is event series, which is a more discrete form of the time series above. And here I want to take a quick look at an example. So here I'm getting Christmas holidays for the United States from holiday calendar. From year 2000 up until 2016. And I'm constructing an event series to plot using date list step plot. And the values are the day values for the holidays, and the time is a series of data objects. And as you would expect, just like in the above plot here, it goes ahead and plots the event series without any problem. But I also want to do the same thing in the second plot, in the plot below. You can see that the data being plotted is simply the values, and there is no date information in there. But there is a second argument to dateless step plot here, which will specify for the plot to treat the values as periodic time data. So here it's telling the plot that the values start off on Christmas Day in 2000, and it's periodic yearly. And so you get the same plot as above, but this is just to show that date plots are not simply getting the encoded date formats and plotting them, but we also attempt to make them like true citizens of this date family of functions. So in this case, we are giving the option for you to sort of retrofit your data with time information so that you can quickly look at what the visualization will look like before you want to. If you want to, you can go ahead and then process your data to add that information back in. Of course, you won't get all the full-blown sort of features that you would get with time series, et cetera, if you wanted to create a time series, but it is a quick and easy way for you to sort of visualize the data beforehand. On the other end of the spectrum, you have data coming in from Wolfram sources. So for example, financial data here, and these packlets contain lots of information in them and many different time series in many instances. And we have a whole class of charting functions that deal with visualizing these packlets. And financial charts do that, and here we're looking at Renko chart that's showing the stock information for Apple. So I don't know why the projector is doing that. I'm sorry about that. So just to summarize, date visualization functions will accept data in any of the date representations in the Wolfram language. So here's a nice little grid that you can see with, on the left-hand side, you have dates as objects, lists, and strings. And on the right-hand side, I'm plotting date histogram for these values. And it knows what to do with it. It takes that information and plots the time information. But just in case you want to give it a time series, it will, again, do the right thing. It'll go ahead and ignore the values and just plot the time. And like we've seen above, if you give a date list plot or a date list step plot the same information, the same time series, then it'll obviously plot the values as well. So the date functions are very smart about what to do with these representations when you give it to them. The same thing is with associations, the keys are ignored, and you get a nice plot of the time. So again, to highlight, if you give the same time series to a date visualization and a non-date visualization, as you can see, the top one will plot the time, the bottom will plot the values. So with that in mind, let's take a look at a very simple data set and look at the different visualization functions and how they deal with it. So here is a data set of holidays for the year 2016. This is derived from holiday calendar data and for a bunch of countries. And the first thing I'm trying to do here is to just plot a date histogram with that data. And I'm asking it to bin by month and give a layout of stacked so that I can actually see the different countries on the histogram. And so this is one kind of visualization you can get from that data. And you can see that January is a popular month for holidays. And if I were to sort of look at this histogram and guess as to which country has the maximum number of holidays for 2016, I would ideally look at the colors and say, take a guess. Maybe Russia. Looks like Russia. I don't know. We'll take a look at it. Timeline plot is a new function that we added, and again, this gives you a different kind of view on the same data set. This gives you more of the spread of the holidays throughout the year. And I have two plots here. One is a plain timeline plot, and the other one has all kinds of labels and tooltips attached to it. And I think it's going to show up terribly on the projector here, but yeah, it has tooltips with flags of the countries. And as you can see, you have a nice spread visualization of those holidays. Moving on, the same data, if you plot it with date list plot, this is looking more traditional now, and you have the time on x-axis, and I've plotted the y values as the number of holidays. So now it becomes clear that Japan is leading in the number of holidays for 2016, followed by Russia, Canada, and the United States, looks like. Date list step plot is yet another new plot that we added, built on top of list step plot. And this, again, gives you a different kind of visualization. And it plots steps where the data changes. And as you can see here, this kind of plot for this kind of data set is helpful to see how much time has elapsed between holidays. So it looks like Germany has like a long stretch without any holidays in them. So when you have date visualization functions that take data in the form of dates, it's reasonable to assume that you would be able to specify options that work on those data to also respect these specifications. And that's exactly what's happening here. We have plot range, and I'm specifying plot range as a date string, and grid lines. I'm attempting to plot a grid line for Independence Day, and that's exactly what you see on the plot there. In addition to supporting options and wrappers and the usual features that all visualization functions have, we also added some new options for the different date functions. And this is one of them that's worth mentioning, which is a date function for date list plot. And what it does is it applies the function to the data on the fly. And if you take this in conjunction with all the functions that work with data, with dates in the Wolfram language, it becomes really powerful. So for example, here, I'm applying date round, and I'm sort of collecting all my holidays for the month to the end of the month. So you have nice steps for each month for the holidays, as opposed to the plot on the top there, which shows you the steps at points where the holidays occur. Date ticks format is another nice option that allows you to format the labels for the time axis. And so for date histogram here, you can see for the same data set, this is just a random sampling of 4 of the named specifications that we have. And in this case, some of them don't make sense because I only have data for 1 year. But you can see that it supports a whole bunch of named specifications for the ticks labels. And you can pick the ones that you like for your data. Moving on, date reduction is a very powerful option for date histogram. What it does is it tells the histogram to treat the data that it's binning as though it were cyclical, reduced to the period that you specify with date reduction. So in this case, you have data for the whole year, for the holidays, and I'm asking it to reduce it to a month. And you can see that the first day of the month seems to be very popular for holidays this year for this group of countries. Time zone is more of an option really for the date functions and the functions that work on date objects. But date histogram does support it, and you can specify the time zone and force the time zone for the data that is being binned. And so in the top plot here, I'm specifying a time zone that is forcing the holidays onto different dates. And so you can see the bins shuffling around a little bit. Yep.
That option, is it like if the data itself has time zones in it,
Yep.
does that override it?
Yes, that does override it.
Okay.
Yep.
But if it's not specified, you can insert it. Either way, it's basically.
That's right. Yep. So let's take a look at an example application. Really, a trading chart is really the poster child for an application built on top of date functions. So this is a financial chart, and it's getting its data from financial data from the Wolfram data sources. But you can see that we are already using date histogram at the bottom here and the date list plot. And we have all kinds of nice controls, clickable controls to change the plot range for the plot. But on top of that, we can do a whole bunch of things that I have no idea what they do, but this is all information that is really encoded in the time series. So you can add all kinds of bands, you can have nice overlays with information from the series that is being plotted. So this is really a very good example of how you can build powerful visualization applications right inside your notebook or your web browser or whatever it is that you're using as your interface. This is really a fine demonstration of what we can do just because the visualization functions now support all these kinds of representations that are coming in from various sources. So what if you want to deal with data that's in the wild? So here is an example with information from a Git repository. So one thing we notice is that version control programs have a lot of data information that can be useful and insightful. So here I'm looking at the kernel repo for the stable Linux kernel. And so you can check that out with Git and extract the timestamps for commits and import it into the Wolfram language. And then I'm doing a little bit of massaging on the data to get into a format that I can easily plug into date objects. And so finally, I have a list of date objects for the commit times for the Linux kernel. And I can go ahead and straight away plug it into date histogram. And this is the histogram of all the commits into the Linux kernel over time. And you can see that there's some weirdness going on here because there's some artifacts because apparently the commits for Linux kernel go all the way back to 1970 and all the way into the future to 2037. So I'm not sure where that's coming from, but you can do a little bit of data cleaning and then you'll get a real nice histogram of the ranges that we are interested in. So nothing, shocking here. The number of commits have been going up over time, and we can do a date reduction on that and see that it's pretty uniform throughout the year. Just a little bit of dip in late summer and probably during the holidays. October does seem to be a month with very high commits or higher commits, and then so we'll probably have the same number of commits this year, similar number of commits this year as last one. And finally, this just a change of look. I'm pulling in some penguins from Wolfram Alpha and using that as chart elements for the date histogram. So really the story is here, I guess, that we can fit all these technologies that we have together and make some really compelling visualizations really quickly in the Wolfram language. Continuing on with the analysis, I want to see the contribution of Linus himself to the Linux kernel. So we can do the same thing. Here I'm extracting timestamps for commits authored by Linus, going through the same drill of massaging the data and getting it into data objects. And here I'm creating a nice association and plugging it into date list plot, and you can see the plot of Linus's commits to the kernel over time. And finally, we can show both of them together, and that's what it looks like. So it looks like Linux kernel has attracted a few more developers over the years. And finally, one last example that I wanted to show you that we built is clock gauge, and it uses a lot of graphics and dynamic technology, but really the core of the information that's showing is dates. And here it's doing its thing using absolute time, and it's telling me it's time for me to stop. So I guess that's the end of it. Just a few announcements. We have a really good page that we built for marketing, which shows all the new features that we added to the Wolfram language since Series 10. So if you have not visited that, I would encourage you to do that. It has really beautiful graphics and really nice applications. There's a talk tomorrow by my colleague Gosha on time series, and if you're interested in the technology behind time series, that would be a talk to attend. And finally, I believe you'll get a survey for the talks that you're attending. I'd encourage you to go ahead and fill those out, because that'll give us more information on what kind of talks you enjoy, so we can put together a good conference for you next year. Thank you.